Okay, done. Hello everyone. My name is Revant, and we are discussing about our final project in artificial intelligence from our professor Ziping Lu. We are from Group 5, and we are going to discuss about these two parts, Part A and Part B. The Part A is about this is a kind of application, and the part B is about we have to select one paper, choose the paper in the below list. So right now we have selected this one, deep learning in financial quantitative portfolio management. We'll go through. First, let me just go through about this part B. Later on, I will explain about part A in the video. Okay. So let's jump into the paper. So we have taken a paper. Let me show you the paper first. So this is I'm gonna submit this paper uh, in the in the in the canvas in the end. Okay. So this is what we are gonna discuss about the in the paper. Okay. So this is the application of Markov decision process model and deep learning in quantitative portfolio management. We have analysis. We had deep analysis on this paper, and we have took some related points, which is like what is this paper suggests about the COVID pandemic. So let me just go through these PPT slides which we have made, so it would be easy for everyone to understand. So let me just so this is about applications of Markov decision process model and deep learning in quantitative portfolio management during the COVID-19 pandemic. I'm gonna add our group name and group members list here. So first, let me go through the PPT slides, each and everything. So the motivation and the signification of the paper behind this is the motivation behind this paper lies in addressing the challenges posed by the COVID-19 pandemic to quantitative portfolio management. The unprecedented market volatility during the pandemic necessitated innovative approaches to navigate the uncertainties and risks. The traditional portfolio management models struggled to adapt to rapidly changing marketing conditions, prompting the exploration of advanced techniques such as Markov decision processes and deep learning. The significance of paper's contribution is multi-faced. Faced. Firstly, it addresses a real-world problem that emerged during a global crisis, demonstrating the adaptability of quantitative methods to unforeseen challenges. Secondly, the integration of MDPs and deep learning signifies a convergence of established mathematical models with cutting edge artificial intelligence techniques, potentially leading to more robust and adaptive portfolio management strategies. This not only enhances risk management but also opens avenues for the incorporation of sophisticated decision making processes in the financial applications. Coming to the major proposal of this paper is all about like the primary proposal of paper application. This the name of the article is to demonstrate the application of Markov's process MDP model and deep learning techniques in the field of quantitative portfolio management, specifically in the context of COVID-19 pandemic. The author aims to show these advanced computational methods can be used to address the challenges of portfolio optimization in the face of market volatility, with the focus on the unprecedented conditions brought about the pandemic. The key concepts and methodologies proposed by the author include MDP model. The paper discusses the use of MDP model to represent the decision-making process in portfolio management, taking it into the account the sequential nature of investment decisions and the uncertain dynamic environment of the market. This is the deep learning techniques. The author explores the application of deep learning methods which involve training neural networks to make a decision based on the large amounts of data in the context of portfolio optimization. This includes the use of advanced computational tools to analyze and predict market trends, particularly during the COVID-19 pandemic. Algorithmic trading and portfolio optimization. The paper dwells into the use of AI-based algorithmic trading to automate the decision making process in portfolio management, aiming to achieve better risk adjusted return and adapt to rapidly changing market conditions such as those experienced during the COVID-19 pandemic. In summary, the paper primary focus is on demonstrating how the integration of the MDP modeling and deep learning techniques can offer innovative solutions to the challenges of qualitative portfolio management, particularly in the unique and volatile context of uh, COVID-19 pandemic. The key concepts and methodologies. When coming to the key concepts and methodologies, here is the three Markov's decision processes, MDP. Okay, let me just. Okay, MDP, the author likely introduced the fundamental concepts of MDP, emphasizing their suitability for modeling decision process in stochastic environments. This includes the formulations of states, actions, transitions, and rewards within the context of portfolio management. Deep learning techniques. This paper likely dwells into the application of deep learning, detailing the neural network architectures employed. This may involve recurrent neural networks, RNNs, or a long short-term memory networks, LSTMs, to capture the temporal dependencies and complex pattern in financial time series data. Integration of MDPs and deep learning. The core contribution is likely the integration of MDPs and deep learning techniques, illustrating how these models complement each other in context of portfolio management. The author may also discuss how MDPs guide decision making while deep learning aids in extracting meaningful features from historical data. What is this? Markov's decision process, MDP. Our portfolio management models operates under the assumptions that agent will invest portfolio over a specified period. So this is the formulations behind the Markov's decision process. MDP is defined as a tuple S, A, P, R, and gamma, where S is this one, a vector representing the environmental information perceived by the agent over time, and A is nothing but is a vector of actions across all assets, actions on each stock. So like this, like we have some couple of variables under the MDP process. So this is a formulation behind the MDP, Markov's decision process. Okay. So for each policies, pi 1 can be defined. Its corresponding value is this one. The management environment of this paper follows the following. Okay. So these are the notations behind the MDP's process. So coming to the data and methodologies, from here, like Umesh will be explaining from now on. You can go ahead, Umesh.
Yeah, hello all. So coming to the data and methodology, here this is the formula here where x of t, which represents one of the OCCLV data, and also it indicates about the technical indications. Now coming to the next slide. So here we can see about the summaries of financial technical indicators, where in the first type here is a moving averages, uh, which it means that simple moving average is, which is short form as SMA, and also experimental moving average, the short form is EMA. And next one is visibility, which means a weight, which it weighted moving averages, MMA, uh, and I mean bands, BBA, NDS. So like this, we mention the names here, and moving on to the next slide. So we can see here the graph on x-axis. We can see the variation of dates from 2007 to 2022, and in the y-axis we can see the price comparison. So here the graph shows that the the test set is ahead in 2002. It was almost 26,000, which is 5 times ahead of the training set. So, and where the validation set is a median, which sets in the median between a training set and the test set. And coming to the next slide.
Yeah,
Yeah.
I will be taking
Yeah.
from here. Okay.
Okay. Hmm.
Yeah, multi-level augmentation portfolio management model. Our model compromises two main components. In the initial session, we applied multi-level augmentation to raw financial data, preparing it for the input into the state space. The second session involved the implementation of the advantage actor critic algorithm. So executed with the Swan Trader framework. Swan Trader framework processes each round, T rounds, through 4 steps. The first step is inputting the data, price data, and the technical indicators. Second one is employing the multi-level state augmentation to enhance a feature quality and feed augmentation features into the state space. The third one is generating trading actions, including buying and selling based on the portfolio and incorporate. The fourth one is incorporating the omega ratio to calculate the rewards and updating the actor networks trading rules accordingly. So the structure of the Swan Trader is illustrated. Okay, that is in the figure like that. That is illustrated on the next coming slide. The multi-level state augmentation as depicted in the figure, consisting of two primary steps: extracting robustness information using the SSDA network and utilizing the LSTM AE to capture temporal patterns and historical information based on the previous observation. Both the SSDA and the LSTMAE networks were trained offline with the training set before the trading process. Only the encoded features were employed in the online trading process to output the informative features. Now you can see the figure which we were talking about in the previous slide. So this is an overview of proposed model. Okay, so this is a multi-level state augmentation module, the whole box. And so as you can see here, this is the following flow, how the encoding layers of SSDA is passing through into rolling data of each assets, and it is going to the encoding layers of STM. These are encoded here, encoding layers of STM, and this goes to here. So this is a raw input. So this is a input, starting input, what we are getting. And so this is how the process works. This the augmentation features, shares, and everything. As you can see the overview of proposed model here. It is a good figure to understand the scenario. And coming to the MSA network, how this is like, as you have seen here, the same thing is explained in detail here. Okay, so whatever you have seen here, this is the same thing, raw data and robustness. This is a encoding layer and a rolling data and LSTM encoder, and this goes here into temporal patterns extraction, and it goes into the state space. So these are the stages of MSA network. So and next, coming to the research models, here we have a stacked pair denoising auto code encoder, so which is called SSDA. These are the formulations behind the research, like behind the SSDA model. So we are employed a stack sparse denoising encoder network to extract latent information from financial data and addressing challenges such as high volatility and low signal to noise ratio inspired by the previous work. We incorporated sparse terms, tested various network designs, and evaluated feature augmentation effectiveness. The SSDA structure shown in this figure, this figure will be explained later. and transforms input data into the extracted characteristics of the nth layer during the fine tuning. The objective of the training is to minimize the squared reconstruction error and incorporate regulations. The denoising autoencoder introduces noise to enhance resilience, and the sparse denoising autoencoder adds a sparsity term for feature extraction. The stacked AE network with n hidden layers is trained layer by layer and fine-tuned to determine optical parameters. So this is something we were talking about in the figure. As you can see in the this is an input layer. No, add noise, hidden layers. This is how it works. So hidden layers two. So you will be having a number of hidden layers in this AE structure, stacked AE structures. So long short-term memory-based autoencoders. So what does this mean? The long short-term LSTM network is designed for the processing sequential data and is widely employed due to its remarkable ability to retain correlations in temporal sequences, particularly in capturing patterns like stock market trends. Unlike traditional RL agents that rely on the most recent state data, LSTM networks can store state information from previous inputs, incorporating historical data into potential features. The LSTM AE, trained similarly to an autoencoder model, aims to replicate the input sequences with the reconstructed loss function identical to a basic AE network. The encoder network identifies a fixed length vector format from time series input data utilized by the decoder network to reconstruct the time series using the predicted value and the current hidden state. So this is nothing but the overview of LSTM AE. You can see the overview of this one, like how the encoder output and repeat vector goes here. And this is how the flowchart looks like, the overall. So coming to the experimental setups and results, the parameter of networks. So several preliminary evaluations were conducted to determine the optimal encoder network parameters. The input dimension is set to this one, 36 and 5 for OHCL data and 31 for technical indicators. Sparsity is applied to up to 10 power minus 8. Regulation set is at 10 power. Pre-training occurs over the 100 echoes and fine-tuning occurs over 200 echoes. The chosen structure for denoising SSDA is for long, LSTM network parameters. The topology and 100 SSTM units are selected for each. So these are nothing but the values which we were talking about here, and gradient clipping with the value of 10 and L to 0.0 in both AE networks. Okay. Metrics. 6 metrics are employed for the evaluation. Profit. They were talking about the values which they have included in our paper. So profit metrics, accumulative rate of return, alpha, risk metrics, maximum drawn down beta. And so let's go to the next slide. So this is nothing but the you can see here you have ONS, anti-core, CRP, CORN, EWES, span trader. Each one represents a different color here. You can see with this one, and you can identify it how the pattern goes. So this is the accumulative return curves of different modules. The x-axis shows the day, and the y-axis shows the portfolio value. Okay. So when coming to the baselines, the various baseline models are compliant, including equal weight, anti-correlation, constant rebalanced portfolio. And these baselines, when coming to the result comparison, the proposed span trader model outperforms all baselines. So this model performance is particularly noteworthy during the COVID-19 market downturn, where it demonstrates the resilience and outperforms other strategies. Okay. So this is a comparison with the main baselines. Okay, you can see here the clear differences between like EWEC, PCS, and span trader. Each one it is shown as a bar graph format, and you can see the values for each one of them here. You can see the value of each ARR, MD, MDM, SR, CMR, alpha, and beta. So each one has a different value for it. So this is the evaluation on different models with the main baselines. Okay. So coming to the analysis and discussion. So this one is the effects of augmentation network to access the effectiveness of the proposed span trade model and understand the roles of the key components. Two simplified versions were employed for the comparison. The first version, span trader only SSDAE, removed the LSTM-AE network, focusing solely on the SSDAE for the state space feature augmentation. Similarly, span trader only LSTM-E was utilized to isolate the function of the LSTM-AE network. The results are illustrated in the coming figures, and demonstrated the span trader strikes a better balance between the benefits and risk compared to the simplified span trader only. So it relies solely on the SSD, so shows a notable increase in the profitable. So this suggests that SSD network enhances agents' risk aversion by augmenting higher level feature, demonstrating its contribution to improved risk control. Span Trader only LSTM-AE. It focuses solely on the STM-AE. So the results indicate this results indicates the network is beneficial for generating higher profits and losses. So when coming to the integrated approach, the result underscores the synergetic benefits of the both components for improved all overall performance. So this you can see in the figures which we were talking before in the slide. So comparison with the different versions of network. So this is a port value and day. So this is the differences, comparisons of various versions of a networks. You can see here HTOS, HTOL, span trader. Okay. So these are the effects of augmentation layer. So this is all about like ST sharp, STR, sort of on the omega ratio, ideal reward function, as we were discussing all about this one, and comparison between these are pretty much same, but you can see here the different values with the reward functions. This is the reward function and this is the versions of the network. So this is the effectiveness of omega ratio. You can see the different values for this one. And coming to the technical contributions, Venkat is gonna explain about this technical contribution. Venkat, you can take it up from here.
Here are technical contributions. Theoretical advancements. The paper may contribute novel theoretical insights into the integration of MDPs and the deep learning potential, introducing a framework that extends existing theories in both areas. Algorithm innovations. The authors may propose innovative algorithms for combining MDPs and deep learning, ensuring efficient and effective decision making in a dynamic context of portfolio management. Result and experimental setup detail on the datasets used training or testing procedure and performance metrics are likely provided. The section may highlight the realism of the experimental setup and the relevance of the chosen data set to the pandemic introduced market conditions. Results, the paper may present empirical result demonstrating the effectiveness of the proposed model in managing portfolio during the COVID-19 pandemic. The discussion may resolve around the model's adaptability and risk mitigations capabilities and comparative performance against the traditional approaches. And the next slide will be presented by my teammate Nageswara.
Darshak. Yeah, Darshak. Yeah, Darshak is
Yes, sir.
gonna explain about this strength and
Yes,
limitations. Yeah.
thank you. I'm going to discuss about strengths and limitations. In strengths, innovative approach, the paper hybrid approach combining MDPs and deep learning reflecting innovations in addressing the challenges posed by the pandemics. In real world relevance, the focus on COVID 19 pandemic adding their real world significance to research, making the proposed to methodology applicable to the similar future crisis. Potentials for the generalization, success integration of MDPs and deep learning may have broader application beyond portfolio management, contributing to intersection of financial and AI. Coming to in limitations, we're discussing about data sensitivity. The model performance may be sensitive to the quality and nature of the data used. The authors may discuss potential bases or limitations in dataset. Computation complexity. The integrity of MDPTs and deep learning could be leads to computational challenges, especially if applied to the large scale portfolio. The paper may discuss computational efficiency and scalability concerns, assumptions and simplifications. The model likely involves certain assumptions and simplifications that may limit its applicability to the divided market conditions and access classes. The author should be the author should be transparently discuss these limitations, and rest of them my teammate will discuss.
Nageshwara, you can go ahead and
Yeah,
discuss about the
thank
feature
you,
notes.
Darshak. This slide is yeah, yeah, thank you, Revant. So this slide is
Yeah.
explains about areas of the future research, like the types of fine-tuning model parameters, assemble approaches, interpretable artificial intelligence, and continuous learning. So if you come to fine-tuning model parameters, this is exploring ways to optimize the hybrid models parameters to enhance for the different market conditions. So if you come to ensemble approaches, like this is investigating the potential benefits of assembles methods to further improve the robustness and reliability of the proposed model. So interpretable AI, this is a developing technique to enhance the interpretability of the models, decisions, and crucial of the gaining trust in AI-driven financial applications. So the final one, if you come to this continuous learning, so this is like adapting the model to dynamically changing the market conditions by incorporating the continuous learning mechanism. So next slides continue by Revant.
Thank you. Yeah, coming to the next slide, it says about the technical depth and complexity. The technical depth of these papers is likely high given the integration of MDPs and deep learning in the context of quantitative portfolio management. Understanding the paper requirements requires a solid grasp of both the theoretical financial concepts and advanced machine learning techniques. The complexity arises from the need to synthesize these disparate domains into the coherent and effective framework, and the comprehensive discussion should delve into the ingredient details of the proposed methodologies, models, and experimental results. So this is the final one, the conclusion. The paper application of Markov's decision process model and deep learning in quantitative portfolio management during the COVID-19 pandemic explores the use of Markov's decision process model and deep learning in quantitative portfolio management. The author suggests in this paper, the author suggests a model-based deep reinforcement learning approach, including deep learning methods to perform the portfolio optimization. The research discussed the application of AI-based algorithmic trading in the context of quantitative portfolio optimization, particularly in the fast-changing environment of the COVID-19 pandemic. The study also models portfolio management as a MDP and provides a detailed description of the MDP modeling process for this application. These findings demonstrate the potential of MDP and deep learning techniques in address the challenges of portfolio management during the periods of market volatility, such as COVID-19 pandemic. So this is all about the paper. We have covered all the necessary things which we want to cover in this motivation and signification, major proposal, technical contribution. So we have covered everything in these points. And let me, so this we are done with part B. Part B is all about the paper. So we have taken a paper and we have analysis we have analyzed the paper and we have made all the points regarding this. And coming to the part A, so this has to be when Jupyter Notebook code. So this is an application where we have to do a code, and let me just get back to the code. Okay. So this is where I have included everything. So let me just run the code first. I have already run the code in the background. Yeah, as you can see here. So let me just show you the code. So before showing it, let me just go through the, so what we want to see, like what is this all about? Final. Okay, let me just tell you what is it. Project 3. So this is what we have to talk about first before going here. So we are gonna talk about SDG, SGD optimizer and neural network. So we have to have the, so we have part 1. So we have to find this one solution. And part 2 is about neural network. Let me just go through the code and show it for you so that it will be. So as you can see here, we have a code running here. This is regarding the part 2 neural networks. Here you can predict the cat. And before explaining this code, let me just go through the report. Okay. So we have ran this one in the Jupyter Notebook, and we have got the expected results. So we are taking all these all these images from the internet, as you can see here, from a link somewhere here. So aeroplane, automobile, bird, cat. Okay, we have just given a class names. And let me just go through the first part where we discuss STG optimizer here. Okay, which we were talking about this, right? STG optimizer. So about this one, SGD optimizer. Okay, we have executed this one also here. You can see the implement gradation. So all STG, SGD optimization code here. So let me just go through the report so that it will be easy for everyone to understand the report. Okay. So when coming to the report, so this is the final report which I have made. So everything, the code and everything has been captured here in this PPT. So the abstract is here, like the machine learning endeavors to enable a computer make decisions based on the previous data unseen. This study focuses on the reinforcement of the module's features weights such as SGD, a widely utilized optimization method for neural network feature weights representing the importance of each input. Prediction creation can be adjusted to enhance prediction accuracy by minimizing the error between the model's prediction and the actual output. The data for this project consisting of coordinates in single hue and including x and y values. The objective is to employ a neural network to identify a curve that best fits these coordinates. The construction of this curve involves various features, and the report should provide a account to update cycles for each. Okay, we are using the Jupyter Notebook files and the TensorFlow framework in this summary. To project seeks to offer hands-on experience with the neural networks and SDG optimization techniques for fostering a deeper understanding and the development of skills crucial for understanding more complex challenges in the future. So the problem statement is this one, which is in the question, and the algorithm which we have used is the algorithm to implement a gradient descent optimizer. So this is what we have done, importing the information found in this one. So this is already given. and creating a function that will allow. So all this has been we have done. So we are gonna upload all these files and the complete report in this in our Canvas submission. So as you can see, the results which we have got from the code. So this is for SGD optimizer. Okay. So I discuss everything about the SGG, so which were asked in the following results. Okay, we have got all these results from the SGD optimizer, and we have everything like we are gonna upload all the zip file which contains all code report and everything in it. And when coming to the second part, it's all about the neural network. It is an image detection using the neural network. Okay, so this is the following code for the image detection. So the motivation behind this neural network image detection is the motivation. The code classifies the images from the CFAR 10 dataset, which consists 10 different categories of images, including aeroplanes, birds, as we have I have shown before, right? In the code, the same thing we were discussing here. The problem is significant because images classification is essential tasks in computer vision with a wide range of applications such as object recognition, autonomous driving, and medical imaging. The performance of these image classification models can have a significant impact on the accuracy and reliability of this application. Finding objects or patterns inside a picture is a technique known as image detection because they can recognize pattern in data without being specifically trying to do so. So neural networks are a well-liked method for detecting images. Instead, a numerous collection of tagged pictures that include the items or patterns they include. The capacity of a neural networks to attain high levels of accuracy is one of the primary reasons for employing them for image detection. Neural networks are the frequently more effective on the detecting methods and approaching, including the manual feature extraction and conventional machine learning techniques when we given enough training data and a well-designed network architecture. Okay, so I'm gonna go through it so fast. So the video is getting long. So this is our output, a desired output we have got. As you can see here, the images are blurred, but this training model is able to find the what is there in the image. If you go to the code, you can see it clearly. So it is just identifying what is there in it. Okay, so predicted cat. See, as you can see, it's blurred image, and you can able to find the like this can able to find the uh, result like exact thing behind the blurred image shape. So here it is predicted shape. Sometimes it may go wrong, so it predicted as shape, but the answer is aeroplane. So the wrong predictions are indicated as a red color, and the correct indications are given as like green color. As you can see here, it predicted right. And so this is all about the code behind the neural networks, and this is the code behind the SDG optimizer. So we are gonna I'm not gonna discuss more on this, since this will be uploaded in our we have done everything, the code and everything, Scotch and gradient descent. So we have got the desired output results and everything. So let me just post this in the submit this in our Canvas. So we have successfully completed part A and part B. So this is all about our final project in advanced artificial intelligence. Thank you. And we are from group 5.
వీడియో స్టాప్ రికార్డింగ్.
వీడియో స్టాప్ చేయి. నాకు రాట్లా.
స్టాప్ అంటే కదా, స్టాప్ రికార్డింగ్ అనేసి.
ఎందుకు ఫోన్ చేస్తున్నావు నాకు? అందరు వెళ్ళిపోయినారా?